Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. I would like to thank everyone who has donated to the show. Your contributions help us make the show sustainable. For details on how to support the show, you can visit our site at pythonpodcast.com. Linode is sponsoring us this week. Check them out at linode.com/podcastinit and get a $20 credit to try out their fast and reliable Linux virtual servers for your next project. And that $20 is now getting you more because they just upped their baseline server to be 2 gigs of RAM instead of 1 for the same $10 price. So go ahead and check them out. We're also sponsored by Sentry this week. Stop hoping your users will report bugs. Sentry's real-time tracking gives you insight into production deployments and information to reproduce and fix crashes. Check them out at getsentry.com and use the code PODCASTINIT to get a $50 credit. You can also visit our site to subscribe to our show, sign up for our newsletter, read the show notes, and get in touch. And to help other people find the show, you can leave a review on iTunes or Google Play Music and tell your friends and coworkers. We also have a discussion forum at discourse.pythonpodcast.com for your opportunity to find out about upcoming guests, suggest questions, propose show ideas, and interact with other listeners. Your hosts as usual are Tobias Macy and Chris Patty, and today we're interviewing Russell Keith-Magee about the BeeWare project, which is a collection of tools and libraries that are meant to be composed together for building up your Python development environment. So, Russell, could you please introduce yourself?
Hi, my name is Russell Keith-Magee. I'm a 10-year veteran of the Django core team, former president of the Django Software Foundation. But as of the last year or so, I've been paying a lot more attention to the BeeWare project, which, as Tobias said, is a collection of tools and libraries for building user-facing applications and tools in Python. Been looking primarily at the mobile space, but also desktop space, TV, set-top boxes, and things like that as well.
How did you get introduced to Python?
I first came across Python about, about almost 20 years ago. This is sort of back around with a 1.5, 2.0 schism that was evolving. It was sort of just an introduction to me as like, hey, here's another language you can play around with. Red Hat was using it as their sort of configuration language, and it really was not much more than a scripting language in that capacity. But it looked kind of interesting, so I had a bit of a tinker and had the first reaction that just about everybody has, which is, oh my God, well, you got syntax significant white space, and then kind of put it on the back burner for a little bit. But then I sort of over time grew to kind of like it a lot more and started tinkering with it a lot more. I had a sort of a background project that I was playing around with going back almost 30 years at this point that I've always wanted to get off the ground, and sort of it become this test bed where I knew the problem space really well, and so I would just kick around. I want to learn a new language. Well, let's try and re-implement what I already know in this new language. About 10, 11 years ago, I came to the realization that this web thing wasn't going away, and maybe the web was going to be a way of solving this problem that I had, and was looking around for web frameworks and sort of fell into Django. Django had just been released, and it just kind of clicked in a way that PHP and Rails and the other options that were available at the time just didn't kind of click. And at that point, sort of my Python usage went from being casual scripting language on the side to being, serious day-to-day programming. Everything that I'm doing in Python type space.
So you gave a brief overview of the BeeWare project, but could you go a little deeper into what it is and what goals you have for it?
Okay, so the BeeWare project actually started in almost a completely different space. About 3 years ago, I gave a talk at PyCon Australia talking about the tools that we as developers use to develop Python. I've been around the traps for a while. I cut my teeth learning to program on Turbo Pascal and Turbo C back in the late 80s. And one of the most notable characteristics of that as a programming environment was that they had a really, really fast compiler, and they had a really, really good graphical debugger, as in like you could step through the code, see where the code was, inspect where all the spaces, all the values, all the variables were, and so on and so on. But if you wind the clock forward 30 years, somewhere in the mid-90s, GCC took over as the C compiler, and we got GDB. Now, GDB is a fantastic debugger, but it's almost toxic from the point of view of a user interface. And my sort of observation at the time was, and nothing's really improved in the Python space. PDB is a fantastic debugger, but it's got an almost toxic user interface that has inherited almost directly line for line for the way that GDB works. So I was positing this sort of theory that the Unix philosophy of do one thing and do it well is a really good philosophy, but it doesn't preclude having a good user interface on the front of that. If you need to show a debugger, then you show a debugger and you show where the lines of code are. You don't try and force it into an 80 by 25, one line at a time console interface. So what I originally started trying to do was build a debugger and do that in Python, as pure Python as you possibly could. And have it so that you could just drop it in and start your project through the debugger and off it would run without having to do all the PDB, import PDB set trace noise that you normally have to do. Now, in order to do that, you need to have a widget toolkit. And at the time, I thought tkinter was going to be the way to do it. Yes, it's messy. Yes, it's old. Yes, it's nasty. But it was there. It works out of the box. You just you just use it, and it's there. But about sort of 6 months in, I started hitting the walls of what tkinter could really do, and I started looking at new options and saying, okay, well, what else can I do? Can I use Qt? Can I use WX Windows? Can I use any of the existing widget toolkits that are out there? And the answer, unfortunately, came back for me as basically no, because what I wanted was a out-of-the-box user experience that was pip install product. And Qt and WX just can't do that because of the way that they work. So I sort of had a bit of a crisis of faith at that point and did a bit of poking around and actually stumbled across Piglet, which is a version of Pygame, effectively, or a variation on sort of advancement of Pygame. And internal to that, it uses a whole bunch of calls to say, hey, let's get a full screen device interface. But it does it without having any compiled C components. And I sort of was looking at that saying, hang on a second, how does that work? And dug into it, and it turned out that, yeah, okay, this sort of Objective-C bridging is actually really easy to do on OS X. So from there, I sort of extended out a bit and thought, well, okay, hang on, that means I can build an entire widget toolkit touching all of the native widgets on a Mac without having to have a compiled component. So I get around the problem of Qt and WX needing to have a C compiler in order to be installed or having something in the system library. So I can just pip install it. Okay, so then the mind keeps going and saying, okay, well, that's fine. That gets me OS X. What about other platforms? Well, okay, on Linux, then it's just, you've got native GTK bindings, so that's fine. That's straight Python. You can use Python straight up. On Windows, well, okay, there's C bindings there, so we can bind it. We can hook into that. But why is someone going to give a damn about yet another widget toolkit if you start working on one? And it sort of occurred to me that the one thing that WX and Qt and all the other options at the moment don't do very well is mobile. We've got this mobile platforms are a thing. They're out there. They're not going away. So, okay, how do we? What can I do all this sort of thing on mobile? Can I start writing Python code in mobile? And so I started digging into that mobile space, and it's effectively 3 years later. Effectively, where I'm at is now I can start popping the stack back out again and say, okay, well now I've got a widget toolkit that I can run Python on iOS, I can run Python on Android, I can write widgets against the native API bindings, and now I can write what I started out to do originally the widget toolkit that can target multiple platforms from a single code base, and then hopefully eventually I'll get back to running the debugger that I wanted to write 3.5 years ago.
So there are actually a couple of other graphical debuggers after a fashion, mostly using the curses interface. The one that's coming to mind right now is WinPDB. So I'm curious what your thoughts are on that in juxtaposition with the graphical debugger that you ended up building up.
I know WinPDB is around, and PDB++, I think, is another one. For me, it's a thing about being native. I have a very expensive laptop. It has a very pretty screen, high-resolution screen. It seems an anathema. No, don't get me wrong, the terminal curses interface is very, very important and very valid, but we've spent 30, 40 years developing these laptops with fantastic user interfaces so that we can use them, not so that we can treat them as incredibly expensive terminal servers. Now, that's not to say that the terminals aren't important. If you do need to log into something remotely and get onto it through terminal, that's absolutely an important and valid use case. But for me, I want to use this tool to the extent of its capabilities, and that means being able to have a button and a pull-down that behaves like a button and a pull-down on the platform where it actually is hosted. So yeah, that's not to say like a lot of the internal tools and techniques that WinPDB or PDB++ are doing are really useful and really especially good if you're having to log into a remote terminal, remote server somewhere and debug your code. But for me, I want to have a pretty user interface, not just because it's pretty, but because that user interface affords more power. It affords better understanding of what's going on. It gives you an easier interface to introspect what's going on.
And so I'm assuming that same philosophy applies to your inspiration for building the Cricut test runner and the Duvet visualizer for coverage data?
That's exactly right. So, I mean, I started with Cricut instead of the debugger because it seemed like a slightly easier elephant to eat. It's slightly smaller. All you've really got to do is show a tree and some test failures. And that was sort of my original proof of concept that this Unix philosophy thing can work. It's a visualizer of test output. A lot of people seem to like PyTest, and it is a very, very good test runner for Python. But for my money, it's still giving you exactly the same output that unit test gives you. It's ... f ... x ... s ... and you don't get any feedback until the entire test suite is run. Whereas if you run it through Cricut, well, okay, the test suite runs. While the test suite is running and you see you got a failure, well, you can go and click on that test and see what the source of that failure was, see the stack trace, see if that's going to cause, that's going to cause 300 other tests to fail later on down the line. So I might as well stop the test run now and go and have a look. And you also can do things like, well, okay, here's a graphical marker on the bottom saying an estimate of how far I am through this test suite and how long it's going to take to run. These sorts of things are things you probably could do if you wanted to do a full cursors screen test runner, but PyTest doesn't do that. But it's sort of the obvious and easy thing to do if you've got a graphical user interface stuck in front of your test suite. And then Duvet is a similar sort of thing. You want to see what lines of code are covered. You don't want that as the lines 17 to 19 are not covered and lines 25 to 35 aren't covered. You want to see lines 17 to 19 and 25 to 35 and see what lines they are so that you know whether that's an important coverage failure or not.
And for Cricut, what does it support, both unit test and PyTest, or do you have different sort of test library that you use for Cricut, or is it something that's pluggable?
Well, it's pluggable in the sense that as long as you've got a unit test like setup, you can build a plugin for it. I haven't actually done anything with PyTest, so I don't know for certain exactly whether we'll run PyTest test suite at the moment, but it definitely runs unit test and definitely runs Django test suites, and they're both there as plugins. So you could, at least in theory, write a PyTest plugin if it doesn't already work. But in terms of the way it works, it is following that Unix philosophy. The purpose here is not to be an all-encompassing IDE with a great big graphical interface you need to configure and all the rest of it. You are using the same mechanism to run your test suite as you would normally be running. All it's doing is manipulating the output of the thing that is running the test, which is, the one unit, the thing that runs the test, and the visualization of what that looks like on the screen is now, rather than being ... it's being a tree that is navigatable while you're still running the test and so on. So the one thing it does well is display the output of a test suite. It's not trying to take over the job of running the tests. It's deferring that to the thing that runs tests well, the unit test framework, and just asks for the input in a format that it can process in an easy way.
And so jumping around a bit more of some of the projects that you have encompassed within the suite of BeeWare tools, looks like there was another diversion that you took in terms of trying to use Python in a browser context with Batavia and Coliseum. So I'm wondering if you can tell a little bit more about that before we dive into the work that you've done on mobile.
Right. The Batavia was sort of an idle thought that got a little bit out of control. I was at PyCon Australia last year, and Ryan Kelly gave one of his regular updates about PyPy.js, which is an implementation of, it is the PyPy source code compiled using Inscripton, which is an LLVM backend that compiles from C to ASM.js, which is a subset of JavaScript that is known to run fast in certain browsers. Now, from that, what you get is a 15 megabyte binary, JavaScript binary, as odd as that might seem, a 15 megabyte JavaScript chunk that is a full implementation of PyPy. So you can do the whole kit and caboodle of what Python can do inside a browser. Now, that's a fantastic technical accomplishment, and full props to Ryan for what he's done there. But for me, that doesn't really cut it, because you can't sit there and ask someone to download a 15 megabyte binary just so you can display a bit of Python code and run some Python code in the browser. So it got me thinking of what do we actually need it to do? What we need it to do is run bytecode in the browser. We don't need a REPL. REPL would be nice, but we don't need it. We don't need a compiler. We just need to say, okay, I've got a validation method on the browser which says is valid. I need that to run in the browser, please. So about the same time, or a little bit earlier, I'd come across Ned Batchelder's and Alison Capo's chapter they'd written for the Architecture of Open Source series, I think it's called, about writing a Python interpreter in 500 lines of code. And it's a fantastic read, and it really does dig into exactly how Python bytecode runs. And it occurred to me that, yes, they've implemented that, a Python interpreter in Python. You could equally write a Python interpreter in JavaScript. It's just got to be running, the code's a little bit different. You've got to have a couple of shims in there. So hang on, if I do that, then I can go and run my Python code in the browser without having to have a 15 megabyte binary, I just need to have this little bytecode runner. And it turns out that bytecode runner is like on the order of 10, 15 kilobyte of code, which is a lot more reasonable. You know, that's the size of your icon image rather than being the size of this giant binary you've got to pull down. So Colosseum then became sort of a part of that picture. Colosseum is a library, it's an implementation of the CSS box model written in Python. Now, if you're, whatever widget toolkit you're doing, you need to have a way to describe where are these widgets going to be on the screen. I originally started out using, effectively, because I come from I use a Mac at home, I use an iPhone, so I do have that Mac bent. As of iOS 6, I think it is, they started using this thing called constraint satisfaction for laying out widgets on the screen. So instead of saying, you know, the classic sort of widget layouts and kind of grid models or box models or whatever, they do it in a very algorithmic sense where you say, I've got a button, the button must be no more than 30 pixels from the left-hand side of the screen, and the second button must be the same width as the first button, but no more than 30 pixels from the right-hand side of the screen. And satisfying that as an algorithmic, mathematical, you know, linear constraint problem, you can come up with where the widgets fall on the page. Now, it turns out that the algorithm Apple is using is something called cassowary, and it's a well-published mathematical algorithm available in math journals and whatnot. It's been a subject of discussion, and there are open source implementations of it. So I figured, okay, well, if I'm going to do this, let's do the widget layout mechanism that's native on Apple, try to get that ported to other platforms, and off we go, which is fine until you discover that Apple's implementation of cassowary isn't exactly cassowary. It's very close, but just not quite. There's a couple little pieces that are slightly different, and of course, being Apple, they don't publish what their differences are. So I was kind of getting a bit stymied trying to reproduce Apple's layout on other platforms. At the time when I was then looking at, okay, hang on, I can run Python in the browser. When you're in the browser, you basically only have one layout option, and that's CSS. But CSS is really good for laying out boxes in general. It doesn't have to be divs and spans and Ps and Bs and all that sort of thing. It can be any box. So, okay, can I use CSS to lay out widgets on an iPhone, for example? And so the answer turns out to be yes. And the reason it turns out to be yes is because React Native came out and they do all their layout using essentially a subset of CSS. They're concentrating mainly on Flexbox. And I contributed to Flexbox, found a couple of bugs in their implementation in the process of porting that to Python, which is what became Colosseum. So, the whole Batavia and Colosseum sideline is in some regards, you know, a bit of a distraction. But by the same token, it's also an interesting little experiment in that it means that the web browser just becomes yet another platform on which you can deploy software. You know, I have desktop software. Desktop software behaves a certain way, has buttons, has pull downs, has all that sort of thing. But there's also the phone. The phone has buttons and whatnot in a certain way, but so does the browser. The browser has buttons and certain user interface conventions and whatnot. And so I sort of managed to roll how do you just deploy an application to our web browser to be essentially the same conversation as how do I deploy an application to the desktop or an application to the phone. And that's what I presented at DjangoCon Europe this year, was a sort of initial proof of concept that, yeah, you could take the same, put a button on a page at the bottom of a list. When you push the button, add an item to the list, contact an API server, get a response back. Do that, write an application entirely in Python, no HTML, no CSS required at all, and push it and serve it as a browser application.
Wow, that is quite the achievement and definitely a very appealing prospect for anybody who is more a fan of back-end code than front-end code, like myself.
And that's kind of, a lot of what I've been driving here is, my undergrad degree is actually in physics, not in computer science. And I migrated because I did want to spend more time doing computing. But my background comes from a space where I'm used to dealing with people, or I come from a community of people who are smart and capable, but not necessarily computer scientists. And whilst I completely appreciate why Objective-C or Swift or these languages and the APIs that Android provides, the APIs that iOS provides, and the APIs that web server provides are very useful and very important and are structured the right way to exploit the capabilities of the hardware, most people who look at a computer aren't interested in learning that. They just want to get something on the screen. Your scientist who wants to do an experiment just wants to capture the data. It doesn't, it can't be a bad user interface, but it doesn't have to be a finely tuned and honed experience as if it was a custom written application. It just needs to get the damn data. So providing a mechanism that says, okay, here is a mechanism which you can say, put a form on the page, get the data, and post it to a URL, and do that as quick as possible is an appealing prospect for a very large community of people. Not necessarily the same community of people that are going to go and step off and write, the next Uber for cats or whatever, but the community of people who just want to have the app that works for them for that one-off application.
So following on to this, at PyCon US this year, you made a presentation about the work you've been doing to bring Python to the iOS and Android platforms. I'm wondering if you can provide a brief high-level overview of that presentation for anybody who hasn't seen the talk yet.
Sure. Okay, so the end point, or the 5-second takeaway, is that you can now, with the tooling that I've sort of put together, you can take pure Python code, you can run it on an iOS application, and you can run it on an Android application. On iOS and Android, you can write that code such that it integrates directly with system native libraries. So on iOS, you want to create a UI button that talks to a UI navigation controller and so on. You can instantiate those objects, you can subclass those objects, you can pass messages around those objects, and that all works tickety-boo. The same goes on Android. You can create an android.widget.button that is being put on an android.widget.list layout or whatever, and you can run all that code. On iOS, it's being done by embedding CPython effectively. You're just compiling Python so that it runs on the iOS device. On Android, that trick doesn't, so at least in my experimentation, doesn't seem to work quite as well. So what I've used is a variation on what I did with Batavia, so taking bytecode and compiling it so it runs in the browser. Instead of doing that, what I'm saying is take the bytecode and compile it directly to Java bytecode, because Python at the end of the day, or CPython anyway, runs as a stack-based virtual machine. Java is also a stack-based virtual machine. So you can take Python bytecode and turn it directly into Java bytecode. They're slightly different bytecode, but they are sufficiently similar that there is a very clean mapping. And as a result of that, you can then say, okay, well, I'm going to write my Android application completely native in Python. Then sort of the layer on top of that is to say, well, okay, then you can write Toga, which is the widget toolkit, or any other widget toolkit for that matter, which under the hood talks to iOS, talks to Android, but the API that you see as an external user is the same regardless of what platform you're targeting.
So let's talk about Toga. How does Toga differ from some of the other cross-platform UI framework efforts for various languages like Kivy or Shoes?
Okay, so the big difference, Kivy is an easier one to map because Kivy is Python as well. The major difference is that Kivy takes sort of a lowest common denominator approach. When you build an application in Kivy and you put a button on the screen, you're not native anywhere. Kivy effectively just says, I've got a canvas. The canvas is the size of my device's screen, or the window that my application is running in, and I'm going to put a button at 10,10, and it's going to be 100 pixels wide and 50 pixels tall, and it's going to have this text on it. And Kivy takes control of the whole process of drawing that button, how that button renders when you click on it, when you press on it, whatever else. As a result, you do end up with a consistent user interface across all platforms. Now, every Kivy app, run it on an iPhone, run it on Android, run it on desktop, they all look the same. But they don't look like the platform that they're on. So it doesn't look like an iOS button. It doesn't look like an Android button. It looks like an alien application everywhere that it runs. Now, for some applications, that's completely fine. Now, if you look at something like a game, for example, games, you're more worried about the aesthetic of the game than you are about how the application looks and behaves. And for those applications, Kivy is fantastic, and it's exactly what you need. But for my money, when I'm dealing with apps, when I'm dealing with things that aren't games where I'm looking for that aesthetic, I want a button that looks like it's system native, and not just looks like, but behaves like as well. If you take things like accessibility, Apple spends a lot of time developing accessibility controls to make sure that people who are hard of sight, hard of hearing, all the rest of it, or motion disabled, are able to use the phone. And they provide all sorts of internal affordances, and they are built into the widgets. But if you use something like Kivy, where they've taken over control of the process, you don't get those affordances. So the idea behind Toga is to use system native widgets. So if you're on iOS, use an iOS UI button. If you're on Toga, if you're on Android, use a android.widget.button. And then the abstraction layer is to say, okay, what's the buttons all are kind of the same. They've kind of got a bit of text on them and they need to respond to a click. So let's write that API and then work out how to manifest that API depending upon whatever platform we're in. I haven't played with Shoes so much. I'm not much of a Ruby person, but from what I am aware of, Shoes seems to be a lot closer. It does seem to be targeting platform native widgets, just doing it from a Ruby side of things. But beyond that, I can't really comment just because I haven't played with it very much. What I have seen, it looks like it may have at least historically still had a compiled C component. So I don't know if its installation story is as simple as gem install Shoes. Given Wise history, I suspect it might be, however that worked. But Yeah, but yes, I don't know enough about shoes to be able to comment in detail.
So that's perfectly fine, and you're right that the native component of shoes was definitely one of the more troubling aspects of it. Someone tried to do a green shoes port where they ported shoes to the JDK so you could take advantage of that. But that's all kind of neither here nor there. I realize I worded the question kind of poorly. What I'm really shooting for here is, for instance, aside from the underlying sort of rendering layer, the fact that Kivy doesn't use native widgets and that Toga does, with Kivy, when you as the programmer build a UI, you use relatively traditional sort of UI toolkit techniques in terms of you use layout managers or whatever they're called in Kivy, layout container types. And, you're calling various APIs as a result of that. With shoes, it used almost kind of like an HTML CSS model in terms of the way things were organized and the way widgets were organized on the screen. And I was kind of curious about what sort of Toga's conceptual underpinnings were in terms of how the programmer interfaces with the toolkit to get the job done.
Right. Okay. So it sounds like, again, I haven't played with shoes, but it sounds a lot closer to what shoes is trying to do. We're using CSS to lay widgets out. You lay them out as buttons inside a container, and then you specify the paddings that happen around the outside of those if you want to augment those, augment paddings away from defaults or something like that. The other thing that I would I don't know if it's a conceptual difference, because I haven't really played with shoes, but it's definitely different from Kivy, is that Toga very much tries to abstract the concept rather than a specific widget. It's a bit of an abstract thing to try and describe, but the best example I can give is that if you look at native iOS, if you ask a yes/no question, the appropriate user interface element is a little on-off switch. There's no such concept as a checkbox to say yes or no. It's like you have this on-off switch to say this thing is on, this thing is off. If you go to Android primarily, if you ask a yes/no question, they use a checkbox. Now, most widget sets that I've seen that are sort of cross-platform will either take the approach of saying, well, we're just going to provide a checkbox widget and draw it as a checkbox widget everywhere, which is sort of the thing that Kivy does, or they will map checkbox onto on-off switch on certain platforms because that's what it's, this seems to be the best mapping for this particular concept. The way or the direction Toga goes is to try and abstract away the high level use case here. So there is no checkbox widget, there is a yes/no question widget. So then you provide I need to answer a yes/no question. I need a response to a yes/no question. What is the appropriate way to render a yes/no question on this platform? And, on iOS, it happens to be an on-off switch. On Android, it happens to be a checkbox. Now, that's a very simple example, but it steps back a little bit further. If you go a bit further than that, go look at desktop platforms, for example. I have a menu bar. My menu bar will have, because it's an application that is running on a Mac, it's going to have a quit item. The quit item, however, is not going to be under the file menu. It's going to be under the application menu, the last entry on the application menu. I'm going to have help, and the help is going to be the last window that's there, and the last menu item that's going to be there. If I ran the same application on Windows, then the quit menu, there is no application menu, but there's going to be a quit item underneath the file menu. So there is this concept of I need to be able to quit my application, but where that appears is platform dependent. So you capture the broad idea of I need to be able to quit this application, and it manifests in the appropriate location in a platform sensitive way. That then starts to get a little bit more abstract when you look at things like mobile platforms and the fact that iOS only has the one physical button, whereas Android has 3 buttons, and one of those can be an in-app context menu, and varies from platform from version to version. But the idea is that you capture what is the high-level use case that I'm trying to do here. I'm trying to ask a context-sensitive question. I'm trying to ask the user to provide input. I'm trying to display a dialogue of some form to let them provide input. And then it manifests for the user as whatever the appropriate widget is on that platform. And so the task then becomes identifying the set of use cases that someone might actually need to answer a question. Now, just to round that out, that actually may mean that in some cases there is a yes/no question and a checkbox widget that manifests slightly differently on iOS, but on Android it is a checkbox and it's a yes/no question, depending upon establishing what the use case for a checkbox is, which may be different to what is the use case for a yes/no question, if that makes any sense.
It does, actually. I can imagine that led to some interesting design challenges.
Yeah, like I say, this is also very, very early stage, so I possibly haven't tripped over all of the rocks that are in my way yet. But so far, it's proven it's been a reasonably good match for the limited set of applications that I've tried to write. There's obviously still a lot of way to go with Toga. It is very, very early stage, but what I've seen so far seems reasonably promising.
So what are some of the biggest challenges that you had to overcome in order to get Python to run on both iOS and Android?
On iOS, it's essentially a compilation problem because it is just embedded CPython on iOS. CPython's compiled using Clang on OS X. It's compiled using Clang on iOS as well. So it's just a matter of working out, what flags do you need to pass into the C compiler to make that happen. When you get a little bit deeper, it gets a little bit messy because you have to deal with FFI, which is the foreign function interface, which is the heavy lifting behind C-types. C-types works really well when it works. When it doesn't, it basically drops you down to assembly. And it turned out that the 3.4 release, which came out in sort of November last year or year before, it worked fine for some ARM processors, so the processor that was on older ARM devices, but it didn't work on newer ones. And then you went and saw a patch that was supposed to work for the newer devices, and it actually just completely broke the build for older devices, and it was all a bit of a mess. So at one point, I was actually having to contemplate learning ARM assembly language just so I could get iOS working, or Python working on iOS. Luckily, someone who knew what they were doing came in and fixed that problem for me, so I didn't have to go quite that far down the rabbit hole. But yeah, just essentially learning exactly how Python's cross-platform build process works and what parts of Python do and don't have to be there in order for Python to compile, and what limitations iOS as a platform imposes was sort of the challenge there. On Android, it became was a very, very long process of trying to do the same thing, trying to do the embedded CPython, and then sort of discovering the limitations that Android puts on applications that are running in the C space. The long and short of it is that Android really, 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 really wants you to be writing Java, but their Java isn't, as the Supreme Court has recently worked out, isn't Java. So there are large parts of Java that aren't there. So Java.nio, for example, just isn't there. So you can't just go and compile Jython. You actually need to be very, very targeted towards Android specifically as a platform and Android's version of Java. So that sort of is the challenge there was to say, well, okay, how can I manifest Python as Android's version of Java? And the bytecode approach actually turned out to be a relatively simple way of doing that, just because it's a relatively low level, but there's only like 150 odd opcodes in the Python space, in the Python CPython bytecode space. So it seems like a really big task. It seems like a really complex task, but it ultimately turns out to be relatively elegant. So yeah, it was a fun challenge, but definitely a bit of a hairy one, and one that definitely gets me some raised eyebrows whenever I mention it.
How does the runtime performance for applications written in Python compare with the same program running in the languages that are natively supported on those platforms? So Objective-C for iOS or Java for Android?
On iOS, it's actually almost comparable. There is a small overhead, but no more so than you sort of consider the general overhead of running Python on a machine. It's yes, you are running an interpreted language. It is interpreting the language on the machine. So yes, there is a performance overhead, but it's certainly well within the bounds of what you would normally expect to see on Python, or Python was running as a desktop application, for example. On Android, there is a little bit more of an overhead because there's a lot of effectively Python boxing and unboxing that needs to happen. So say, for example, you've got a Java interface that accepts an integer and a float and returns a float. So you need, if you invoke that through Python, you need to convert the native integer into a Python integer and the native float into a Python float, multiply the integer by the float using Python's rules for multiplying integers by floats, and then return a Python float by unboxing the Python result back into a Java result and returning it back through the API. Now, the bad news is that obviously there's a lot of object creation and destruction going on there, and ironically, the two things that Android does really, really slowly, the Java virtual machine does really slowly, are creating objects and creating exceptions. So that is a slowdown. It is a significant slowdown, but it's certainly still within the bounds of, at least from my testing, it doesn't manifest as a poor user interface or a slow user interface. The good news, though, is that the VOC, the compiler that you're working with, because we're able to use, or we are using, Python 3's type annotation syntax to say, okay, this thing is a method that accepts an integer and accepts a float and returns a float. We have all the typing information to do some very hardcore optimization. At the moment, VOC is still very, very early stage, and I'm well and truly at the point of let's get this working rather than let's get this working fast. But when we do get to the point where it's working well enough, there is a very clear path to making it working much faster than it currently does. There's a lot of things that I'm doing mechanically to create and then destroy an object that's a box when I don't necessarily need to. The compiler has, or I have enough information to know that this is only ever going to be an integer, this is only ever going to be a float, therefore I can do this primitive operation and never have to go through the boxing process. It's just a matter of the sort of time and effort involved in writing an optimized compiler that's type aware and knows when that boxing can be done or can't be done.
And so one of the things that you brought up was the slowness of exceptions in Java, and idiomatic Python generally uses exceptions pretty regularly as sort of a flow control technique. So I'm wondering if, particularly for Android, but also for iOS, if writing your applications in Python requires some change in idiom in order to get it to run in a sane fashion on those platforms.
Okay, so it depends whether you're writing against the native platform or you're running against the Toga abstracted API. If you're writing to the native platform, yes, you are very much going to be writing, at least at some level, you're going to be writing ObjectiveC in Python, because you just can't get around the fact that you have to instantiate a UI navigation controller that has all these objects and whatnot around it. So that, like things like exception handling on iOS works just as quickly because it's essentially exactly the same exception handling that's happening on the machine level. On Android, that the same thing applies there. If you're writing directly to the Android APIs, you are writing idiomatic Java in Python. The good news is that when you go back one level though and you start writing in Toga, that you can start writing idiomatic Python. So one of the things I've been able to do is, say, for example, button handlers. When you click on a button, Java, iOS, they both say, okay, well, you've given me a callable, or the Java iOS equivalent of a callable, and you invoke that method, and it's a callback. And if you need to do something long running, then you've got to put it into a thread or do some sort of deferred process in there. Doing it through a level of abstraction means that at least at the first level, it's very, very easy to say, well, okay, I'm just going to make that a generator, and the generator will go there and you say, okay, do a small amount of processing and then yield to the event loop, and then do a bit of processing and a yield to the event loop. And I haven't quite got to the point of integrating completely with the iOS event loop, but it's on the conceivable, not far from on the horizon, being able to do Python 3.5 async by just saying yield from a HTTP handler, for example, or a requests handler, and that just being an asynchronous call that behaves as an asynchronous call without actually having to do any of the underlying juggling that you would need to do asynchronicity on the ObjectiveC API. So the moving back a layer into something like Toga does afford writing idiomatic Python in Python. You just you need the layer in the middle needs to exist so that you can have an API that doesn't expect you to be writing ObjectiveC effectively.
That's awfully cool. And I think it's also really neat how Python 3's async being built into the core, a lot more people are leveraging it. I think you're really going to see Python start to be used in more of these async friendly use cases where people may have shied away from it in the past.
Yeah, no, I agree. And I suppose it's one of these interesting transitions that's kind of a bit like the Python 2 to Python 3 transition. I lived through Django's transition from Python 2 to Python 3. And initially it was, no, we can't do it because PsychoPG, the database layers, don't have Python 3 support. So we can't, Django, there's no point Django porting over because we can't talk to a database. Eventually, the database layers all become Python 3 compliant. And then the stack move, the expectations of the stack move further and further back. Right now, we're at a position where, there isn't, to pick an obvious example of something that I've hit against and is likely to get hit against many times in the future. Requests. You want a simple interface to say, hit this API, hit this REST API, get back some data, and display it to the user in some meaningful fashion. Requests is a fantastic API, but it isn't asynchronous. And so, because then it's a blocking call. Okay, so we need an asynchronous version of requests. And there are a couple of those floating around, but they're all, at the moment, from what I can tell, using green events or G event or variations like that, using the various monkey patching sort of techniques to make an asynchronous-like API. What we really need is a version of requests that is written in using Python 3.5 asynchronous primitives. And when that happens, then all of a sudden you can start writing asynchronous user interface applications that just call off to get an API call and come back as soon as they've got the results and process them and display them. Now, I know that, for example, Twisted, I'm good friends with Amber Brown. She's constantly chewing my ear off about how we could be using Twisted in this context. And yeah, absolutely, that's definitely something that's there. And Trek, which is the Twisted's Twisted integrated requests framework is there as well. So there are options and there are things on the horizon that exist now. The long-term picture, though, is things that are in the standard library or just exploit the standard library that use async as if it was a completely native thing. Now, that obviously is going to take time, but time's something we have. It will, I think, eventually happen. It is literally just a matter of time and someone having enough inclination to go off and do it.
So can you walk us through the low-level flow of a single Toga API request? Like, for instance, one of those yes and no answer widgets that you were talking about previously, say being called for the iOS platform.
Sure. Okay. So on iOS, you have a Toga import. Import Toga, toga.widgets. Yes, no button. That is a Toga interface. That Toga interface has an API that is consistent across platforms. And so a yes, no button, it needs to be displayed. It might have a label, and it needs to have a callback every time it's toggled, for example. And you need to be able to ask it, what is your current state, yes or no, and give it an initial state, yes or no as well. So that external API shim, when the object is instantiated or when it's sort of manifested for display purposes, that Python side native object gets a underlying implementation, an underscore impl object. And the underscore impl object is the platform native manifestation of this widget that needs to be displayed. So in this case, it'd be a UI switch, I think it is on iOS. So you'll then have a Python object that contains a pointer to a UI switch, which is then implements the full set of callbacks and everything that a UI switch could possibly have. So regardless of whether you're actually calling it or not, you then have a button, when I'm changed callback and when I'm set my name callback and everything. So when you call an API on the external API shim, it effectively is a proxy for self.underimpl. Do whatever you've got to do on that native platform. There may also be, depending upon exactly what platform you're on, for example, you might need to have a container or a view controller or something, and that will then be part of that instantiation process. So the impl is the object you're actually dealing with, but in order for that impl to work, you need to have a bunch of other stuff around it. So it'll instantiate those and connect them up, plug them in, however they need to go as well. As far as iOS, this is where iOS and Android then start to differ. So if it's on Android, then effectively that object that you've just instantiated is a Java object, and you just start calling methods on it as if it was a Java object, because the Python bytecode gets compiled to Java bytecode. You get a java.class file, and it just runs as if it was Java. At that point, it's a similar sort of thing as if you're using Scala or something. The input language doesn't matter. It's running as a JVM binary. It's got JVM parts associated with it. So it just runs as if it was Java. On iOS, it then needs to go through a little bit of a trick. So the little-known secret about Objective-C is that although it's got a magnificently Baroque syntax, is that it is ultimately just a very, very thin shim around C. So the open square bracket object, message, colon, value, so on syntax actually completely reduces to a series of raw C API calls. Because it's raw C API, you can access that using C types. So what Rubicon, which is the sort of library that does the bridging between the two platforms, does is it does a whole bunch of sort of Python metaclass and decorator and other sort of magic to say, okay, well, I'm going to have a Python class which, when it's instantiated, ties to this underlying Objective-C instance or ties to this underlying Objective-C class. And when I request an attribute on this Python class, that's going to turn into this C API call, which is effectively a message being passed to the underlying Objective-C object. So there is a sort of this proxy layer which turns Python attribute requests and Python method instantiations into the equivalent underlying Objective-C calls by calling directly into the mechanisms in Objective-C that make that work. And at that point, you're basically talking directly as if you were Objective-C. There's you're passing messages, you're receiving responses, you're instantiating objects that you're passing in as handlers or whatever else. And so when you press, you click on the button in the user interface, you get the Objective-C layer wakes up, says, okay, I've got to call my I've been clicked handler. That says, okay, my I've been clicked handler is this object. This object is actually a Python object, which wakes up the impl, the under impl version in Python, which then calls back onto the public API, which is the Toga interface, and invokes whatever handler's been registered there as a native Python handler against that button click.
Wow. As I want to echo Tobias's sentiment a bit ago, that is quite a technical achievement unto itself. When you think of all those different layers working in orchestration and providing, it sounds like a relatively simple conceptual interface for it all at all the different levels that it's working at. That is really quite a design. Thank you for laying that out.
Yeah, well, I wish I could take a lot more credit for it than I actually do. This is one of those situations where I really am standing on the shoulders of giants. There are like that approach of using the Objective-C API is not something that I invented at all. It's something that I became aware of through Piglet. And effectively is exactly the same approach that PyObjective-C uses, which now ships with OS X as their sort of native Python bindings to the Objective-C API on a Mac. So the approach is not new by any stretch of the imagination at all. The only sort of thing that I've added to that picture is I've introduced Python's type annotations and cleaned up sort of the way that you can register this stuff a little bit. The older versions, because they're on Python 2, you had decorators that had these sort of weird text encodings of what type annotations would be. So now I can actually just describe it in Python as if it looks like it's Python and :int rather than a variable name that's actually a Z or something. So yeah, This technique is not something I invented. It's just something that I'm exploiting, and I'm happy to tell people about it because it is at the end of the day a very elegant approach. But at some level it's also this sort of the same sort of underlying thing about where BeeWare came from, about being the Unix philosophy of doing one thing and doing it well. There are multiple little problems here that need to be solved in order to get Python running on on a mobile device. There is the underlying core problem of I need a Python runtime that works on this machine. So I need to be able to say print hello world and have it do something. It doesn't have to interact and throw a button up. It just needs to display and run. And you can do that. And that's what the Python iOS support library is as far as BeeWare is concerned. That is independent of the problem of can I write Python code that talks to the native system bindings? And that's what Rubicon is. And then on top of that, you need to be able to say, okay, well, now I want to have an abstracted layer that allows me to create a button without having to care what the native platform is. And that's what Toga is. So it's a series of layers on top of layers on top of layers. Each one of them does one task, does it hopefully well, and builds on top of those. Each one of those is an independent project and can be maintained and completely independently of everything else. So you can say, here is Python on iOS. It doesn't talk to system native bindings, but it does let you run Python code on iOS. And if you want to fix it, that's the only problem you've got to deal with. You don't have to deal with whether or not it can talk to a UI button. You just got to say, can my Python code run? And then when you start talking about Rubicon, you can say, well, okay, assume that Python runs. How do I get this to work? What do I need to do? How do I improve this? How do I improve the bindings and so on? When you get it to Toga, you say, okay, well, I'm just going to assume I have access to the system native bindings. How do I display an API that is clean and elegant and provides a Pythonic interface for developing user interface applications?
Yeah, that's definitely one of the best arguments for the benefits of composition that I've heard. So definitely agree that, like you said, having the distinct responsibilities for each layer will greatly simplify the model and the amount of effort required at each of those layers to actually get something that works and is maintainable.
Yeah, no, I agree. And it's also interesting from the point of view of project maintenance. Has made my job a lot easier because I've been very aggressive about trying to get new people involved in the project. The smaller the chunk, the more consumable the chunk, the easier it is to get people involved because you don't have to say, well, here's this 1,000-pound gorilla. You have to defeat all of him in Mortal Kombat. No, you just need to understand this one little part. And if you can make that one little part work, assume the rest of this works, but make this one little part work, you can make a contribution. So having it composed like that, just as a sort of as an ontological thing, makes it a lot easier to get people involved because you can point them at a specific thing that doesn't work and say, assume the rest of it does, now make that other part work a little bit better.
So do you view your work on Toga and the associated libraries as a hobby project, or do you think that it'll turn into a production-ready toolset that people will use for shipping production applications?
Depends when you're asking that question. Right now, it's a hobby project with delusions of grandeur. Longer term, I'm sort of in this interesting situation at the moment where I'm kind of, I am convinced. I think there's a whole lot of possibility here, and I would like to spend a lot more time working on it. I don't think we're that far away from being able to produce very realistic shipping applications. My day job at the moment is doing back office software for plumbers and electricians, and I have a cross-platform mobile app that I've written in PhoneGap, and every time I touch it, there is a very good chance that someone's going to die because it just drives me insane. A lot of what I've been doing is kind of trying to develop this tooling to the point where I can use it realistically to replace this mess of PhoneGap code with something that's written native and is in Python. I don't think we're that far away from it, but it's, if it continues to be me working in my spare time, which is primarily what it is at the moment, it's going to take a lot longer. I am actively looking for ways to fund this. Funding open source development of tools that people think might be useful or would be useful if only someone could focus on it. That's a problem that I'm definitely interested in solving. And just on a completely personal note, I am very much interested if anybody happens to have any great ideas about pots of money that might be useful for achieving this sort of thing.
Yeah, that's definitely a recurring issue in open source, and one that as yet is unsolved for the general case. There are some particular arrangements that work out well, particularly if you can engage in development of that project as a consulting engagement, but it doesn't always work out that way, and sometimes people don't want to put themselves in that situation because doing that extra work on a consulting basis can either potentially change the direction of the project or just suck even more time from somebody's limited allotment.
Yeah, and there are some competing motivations in that. If you take, for example, your getting started guide and make your out-of-box experience. If you are a consultant whose job is selling a custom configuration for getting this project going in your given environment, it is against your economic interest to write a better getting started guide. Because if you've got a better getting started guide, you don't need to contract a consultant to help you get things installed. So there's kind of this, if the thing that the project needs is better onboarding documentation, I'm not going to write it if that's going to kill my ability to feed my children. So there is an absolute tension there. There's also a huge tension between the difference of a project like where BeeWare is at the moment, which is sort of a useful proof of concept but needs another year's worth of development maybe before it's, absolutely use it for everything you need it. You could possibly use it for, versus something like Django, which is well established, well out there, lots of large companies already using it. And what it really needs is just kind of maintenance and bug fixing and occasionally some new features, sure. But there's already the product is there and it works. So it's a lot easier to sort of sell the services around the outside of an established project versus one that doesn't really exist yet in the sort of the mature sense of the word.
IDEs like Android Studio and Xcode have a lot of features that simplify the development and UI creation process. Do you have to forgo those niceties when developing a mobile app in Python?
Right now, yes. So right now you are writing code like if you actually want to sit down right now and write an application that was in Python and for a mobile app, you probably realistically would be doing it against system native APIs, and you'd be developing it only in code. It would be raw code, putting widgets on screen and stuff like that. Longer term, there's absolutely no reason that has to be the case. And interestingly, because it's being done in a browser, there's a real possibility there to sort of say, well, okay, here is a browser-based layer for displaying all these widgets on the page and using the CSS that the browser has to display how they work out how those widgets are going to appear. Now, okay, turn that into a configuration that can then be saved to disk and manifested when I next start my application, either be it as a web-based application or native device code that's reading a configuration file and building widgets on basis of that. So the short answer right now is that yes, you do. The long answer is that eventually you shouldn't have to. Again, this is purely just a matter of time and resources and all the rest of it. I have an image in my head of all sorts of things we could do. It's just a matter of getting there.
Yeah, and one of the features that those IDEs generally provide is facilitating the build process, and shipping applications for Python is a problem that has historically tended to pose a host of issues for people, and it looks like you're at least attempting to address some of those with the Briefcase project. So I'm curious what some of the biggest hurdles and design choices you've encountered while working on that happen to be.
Yeah, sure. So, I mean, Briefcase, just to fill in the gap there, Briefcase is sort of the last piece of the puzzle. So once you've got Python running on mobile and you've got a bridging library to talk to native system libraries, you've got Toga that lets you build an application in a platform's independent way, Briefcase is in the tool that you can say, okay, take this Python project and make it run as an OS X app, make it run as an iOS app, make it run as an Android app. The biggest hurdle, honestly, the biggest hurdle I've had with that is just working out what's actually possible. The internals of distutils are Baroque. Not broken as in Baroque. They're eclectic and not especially well documented in my experience. So it's sort of been a process of, hey, you can actually build a plugin that's the equivalent of BDist RPM, BDist wheel, and have it spit out something. I've also benefited from using Cookie Cutter there. Audrey Roy Greenfield and Danny Greenfield Roy, I forgot their names right, to roll out project templates effectively. So the technical issue there is really just working out what is an app on a given platform and how do I make that happen? So on iOS, it's an Xcode project that's rolled out. On OS X, it's a .app directory that just happens to have some magic metadata in various places. At PyCon a couple of weeks ago, I got a huge amount of interest from people wanting this working on Windows, and I've got some ideas about how that might actually work without too much drama. So shipping Python applications and having it appear on someone's app, give them here is my ball of code. The end user, there are some use cases like a debugger, like Cricut, like Duvet, where you do genuinely have to care that this is a Python project because you're running a Python debugger over Python code and you want it to run inside your virtual environment with the environment that your project has got set up. If you're running a user-facing tool, the end user should not have to care that they're running Python. They shouldn't have to configure their Python path. They shouldn't have to modify their environment variables to make sure that it can find the Python interpreter. It should just be, here is a ball of code, run it, or install it using whatever process that user's native platform happens to be. And that is something that Python has not historically done well. That's something that Glyph Lefkowitz has been very vocal about of late. And I think he actually spoke about that at PyCon as well. And I'm definitely interested in sort of this big picture of making Python a viable option everywhere. That's a big problem that does need to be solved.
Have you looked at all at the work that the Kivy team has done with their Bulldozer project?
I've done a little bit of looking at it. Part of the problem, I don't like sort of smack talking on Kivy because at the end of the day, Kivy is a working alternative and Kivy does work very well. My experience, though, is that Kivy is very focused on building Kivy things, which is fine. And it does mean that they can document their Kivy stuff and it spits out Kivy code very well. But my experience at trying to get Kivy things to work outside of Kivy has been very, very painful. And in particular, they've got some technology choices, in particular things like Python, that I just can't get my head around. I know Python works. I know a lot of people like Python quite a bit, and power to them if they want to go ahead and use that. But from my perspective, it's a little bit it's just a little bit too flaky for me to enjoy using it. The first time I used Kivy, I ended up spending a couple of weeks trying to work out why something wasn't working, and it was because of a point release of Python that broke something that Kivy used. And for me, as soon as a C compiler gets involved, if you're talking about a Python project, you've already lost the game. I have had a brief look at what they're trying to do. I haven't had a detailed look at where they've ended up with that. I'm certainly open to talking to anybody from Kivy if they want to combine forces and end up take over the world that way.
Closing it out a bit, do you think that there will ever be a release of iOS, Android, or even a brand new mobile platform that will actually just ship Python with native support?
Dream of dreams. I would absolutely love to be able to say yes. Realistically, I don't think iOS or Android are ever going to fully embrace Python. I would certainly be very, very happy to be proven wrong, but iOS seems to be very much putting all of their eggs in the Swift basket at the moment. Android is... I am waiting for the day that Android says that Java is no longer the way they're doing things, just because the legal situation with Oracle just can't last in my mind. But I don't think that the answer to that is them going to be embracing Python as the preferred or even a particularly blessed option on their platform. They've had people in the Android team who have done, there's a scripting languages for Android layer, and it's the way they've chosen to do things is just, yes, it makes sense in Android, but it's really eclectic and isn't really an option for shipping actual Python applications where the user doesn't have to care they're running Python. So I think the best we can hope for is a slightly better situation of where we are now, where it's kind of not blessed but not actively discouraged either. Which is kind of where we are with iOS, and Android is kind of ignoring the problem at the moment. iOS has a set of rules that say you can run scripting languages as long as all the code that runs is either user entered or provided in the application tarball. Explicitly getting a little bit more explicit about that and saying they're not going to pull the rug out from under that would be nice. A brand new mobile platform, I certainly wouldn't turn that down, but it's sort of one of these situations where someone with a giant pot of money needs to sit down and provide a device that everyone can buy that has native Python support on it. I would love to think that that's going to happen, but realistically, too many people have tried, and we've already got two incumbents, neither of whom is going to be displaced unless there's a nuclear strike on Mountain View, essentially. So I don't think we're ever going to be as native as I would like Python to be, or as native as I think Python deserves to be as a language. But that doesn't have to stop us. We can still eke an existence out as the second cousin that gets invited and can still do interesting things when they need to.
Yeah, I'm wondering what's going to end up happening with the native development kit layer on Android, whether that's ever going to provide for some broader utility outside of just having some performance optimized backend code that gets executed, whether that they're going to let that tie into the UI at all.
And that's really the killer point. If they ever expanded the NDK to be something where you could actually get access to an Android.widget.but, then all the stuff I've been doing with Voc goes out the window. You don't need to do that. You just go straight to C API and invoke whatever you need to invoke. The catch is I don't think they're going to do that. They might, and I could be proven wrong. But so it really does hinge on getting access to system native code without being forced to go through the Java libraries, because it's the JNI layer that really makes everything a nightmare on Android as a platform. And that's why I ended up saying, well, let's not worry about JNI. Let's just go straight to Java and talk to the stuff as if it was Java. It's certainly not the best answer, but it's also, interestingly, although what I've been doing is with Voc, the Java bytecode compiler is targeted, or the reason I'm doing it is so that we can run on Android. There's absolutely nothing Android specific about it. So I know I did over the PyCon sprints, just as a proof of concept, spat out a swing application that was written in pure Python. And, it was like 15, 20 lines of code and fairly idiomatic and made a bunch of sense. But there's no reason you couldn't do that for Swing. You could do it for J2EE. You could do it for a Minecraft plugin. You could do it for a PyCharm plugin. Anything where it is a native layer that where the native platform is Java. Java's, despite Oracle's best efforts, isn't going anywhere in a hurry. So, that's a platform that it behooves us to have a good Python answer for. And Jython is also a very good answer in that space, but the Jython team suffers the same sort of problems that I'm suffering of finding resources to actually back it.
So, are there any questions that we didn't ask that you think we should have, or anything else that you want to bring up before we move on?
No, nothing specific. I mean, it's the one thing that I sort of throw out there is as an open offer, and it's something I've said on Twitter on many occasions, is that young projects don't get anywhere if they don't get people involved. So I have been very, very active about saying that anyone who wants to become a contributor to any of the BeeWare projects, I have an open door offer to anybody who wants to become a contributor. Because we are an early stage project, a lot of the things that need to be done are very low hanging fruit. At the PyCon sprints, we had at its peak something like 6 tables of people, 6 full tables of people who were contributing. We introduced 45 new contributors to the BeeWare projects over the space of a 4-day sprint. And some of those people, like one of them, one woman in particular, had only really just learned how to code, and this was sort of her first time really using GitHub, and she now has commits in Voc. So this is not Voc, in Batavia. So I have an open offer to anybody who wants to get involved. Just hit me up on Twitter, hit me up on the contacts through the website, and you should be able to find me, and I can walk you through the process of getting involved.
Great. And that leads us nicely into asking what are the best ways to keep in touch with you or follow up or ask questions or ask for help.
For sure. So the BeeWare project as a whole, its Twitter handle is PyBeeWare, PyBeeware. Our website is pybeeorg, and from that you should be able to get just about anywhere or contact any of the other projects. There's a lot of GitHub stuff all under the PyBee organization on GitHub. Yeah, from there, get in touch and we can find something for you to work on.
Great. So with that, I will move us on into the picks. For my first pick today, I'm going to choose a Japanese cast iron tea set that my wife got me recently. So I've been drinking a lot of loose leaf tea, and it's a really nice way to have a small personal sized pot of tea or enough to share between two people. And it's been great to use. The cast iron holds the heat so that it will keep the tea from cooling down too quickly, and it comes with two nice little cast iron teacups as well, and it's all enameled on the inside. So definitely pretty great for anybody who likes tea. And with that, I will pass it on to you, Chris.
Great. I just have two picks today. The first pick is a cidery that is local to me here in Somerville, Massachusetts, called Bantam Cider. They make some great stuff. I'm generally not a big fan of cider because most of it from most places tastes like apple juice to me. But they make some really interesting things, including one called a hop scrumpy, which is a hop-based cider with very interesting stuff. And it's a fun place to visit if you're Boston-based. I highly recommend it. My next pick, speaking to Python on mobile devices, actually, Pythonista, which is an iOS application that I have rambled on about here, being very impressed with, has come out with Pythonista 3 for Python 3, and they've added a bunch of other enhancements. I can't say enough good things about this app. It is just such a pleasure to work in. I've really enjoyed it when I'm on the road or whatever. I can play with Python stuff, and people, in fact, have written a version of pip for it. It's a really great tool that I wish more people knew about and supported. And Ole Zorn, if you're out there and listening, I would so love to talk to you about this on our show. I think it would be really cool.
Maybe I'd help you out with that because I'm the reason it runs on Python 3, strangely enough.
Oh, really?
Yes.
Oh, that's fantastic.
Ole contracted me to do the Python update, the Python port that I've been doing to Python 3.5. So thanks to Ole's funding, the Python iOS project got a little bit of money for us to get that going, get Python 3.5 port working, and he obviously got a nice kickback in that he's able to release Pythonista 3. So
it's a small world. That would be fantastic. And with that, I'll pass it on to you, Russell. What picks do you have for us?
All right, my pick for today is actually a slightly off top. Well, it's sort of in the sense of Tobias's Japanese cast iron tea set. It's a slightly off piste. Something I've been very open about over the last year. About a year ago, I went through a very, very rough time, sort of post inspection of what had been going on. It had probably been going on for somewhere between 18 months and 4 years. One morning, I woke up. I went in, sat in my home office. I worked from home. I sat in my home office, and about 9:30 in the morning, I literally could not summon a damn about anything. And I went back to my bed and I cried for a couple of hours. That was sort of the culmination of a lot of niggling back pain, niggling shoulder pain, very short temper, and a variety of other things that have been happening in my life for a very long time. And my wife gave me a very firm application of boot to rear end and got me to go see a doctor. And I was diagnosed as being in the middle of a major depressive episode. So wind forward 12 months, I certainly can't claim that I have defeated that in any sense whatsoever. I'm still in a constant struggle on a day-to-day basis with depression. But what I will say, and the reason that I'm being so open about it, is that this is something that happens very, very frequently in our community. It's a very, very present problem in open source and a very present problem in software development in general. We hear about burnout, and in the most extreme cases, we hear about people taking their own lives. And one of the reasons that it's such a bad thing is the stigma that's associated with mental health and the stigma that's associated with dealing with these problems. Now, so I'm hoping that by myself being open, that I can help reduce some of that stigma. And certainly the experience I've had when I've spoken about this at lightning talks or given talks at conferences is that there are a lot of people who want to talk about this but don't feel they can because they feel they'll be putting their career in jeopardy or their friends won't respect them or something. All I can say is that if you are in a situation where you don't feel like you're coping, where you feel like the world is getting to be too much for you, please seek help. And if you're in the position where you're considering whether or not maybe you might see someone, then the answer is almost certainly yes, you should go and see someone. because you don't have to live like that. Life is supposed to be enjoyable. Life is supposed to be fun. If you are finding yourself in a situation where life appears to have lost its joy, where you're finding it very difficult to find the motivation to just get out the door and do something, do anything, then please seek out professional help, be that psychologist, psychotherapist, doctors, whatever you can find and whatever you can get to hand. There are a number of organizations that, both in the sort of the general wider community and also inside the tech community, that can help point you in the direction of resources in terms of finding support, finding useful mechanisms that might help for you. And all I can do is sort of encourage you to seek out those organizations if you can. And I will drop some links in the show notes to places that might be worth hitting up.
All right. Well, thank you very much for that. It's definitely, like you said, a big problem in the community and something that needs to be addressed as readily as possible. So I appreciate you sharing that. And I also appreciate you taking the time out of your day to join us to tell us more about the work that you've been doing with the BeeWare project. So I appreciate that. And I hope you enjoy the rest of your day.
Well, thank you very much. It's been an absolute pleasure. And I encourage anyone who wants to get involved, please come and hit us up on the project, where we've got lots to do. And I think the future of Python in any number of environments is very, very bright. We just need to close out this last little loop of building user interfaces.
Thanks. Good night.
Good night.